Hi, welcome to all you brave people out there. I hope that you've been practicing your trigonometry and are now ready for our Going Beyond lesson, our lesson on using angles of elevation and depression. By the end of this lesson, you should be able to use a diagram to represent angles of depression or elevation, decide which triangle to use, and decide which trig ratio to use. Pythagorean has been trapped by a new enemy, the tangent. After a long struggle on the roof of a very tall building, Pythagorean manages to escape. He jumps and lands on the roof of an adjoining building, but the tangent is close behind him. Pythagorean shoots out a magic line to the opposite building to stop the tangent from leaping across. The tangent is caught by surprise and falls and lands at the foot of the building. But how far did he fall? Will he be able to climb back? Wait for the next exciting episode of Pythagorean. I don't know about you, but I don't think I can wait to find out how high the fall was or whether the tangent would be able to climb back up. I think we should work this out right now. But to do this, I think we need to recreate the scene. Let me have a look and see what's like around here, okay? Here's a box, let me see. Pythagorean, Mr. Tangent. Here's some string, more string, some tape, a ruler, and I think I'll use this as one of the buildings. Now I need a taller building. Let's see this box here. There we go. I can use that as a taller building. Right, I think we're ready to set the scene. Okay, so we'll have this as the one building, and we'll have this as the other building. And why don't we put Pythagorean and Mr. Tangent up there? Okay, so let's see what happens. Mr. Tangent is chasing Pythagorean, and they're both on top of this building. Pythagorean leaps across to this building, but Mr. Tangent is right behind him, and he's going to continue chasing him. So Pythagorean shoots, yes, that's it, let's use that string. Pythagorean shoots this magic line from where he is on that building straight up at Mr. Tangent. Let me tape that there. Mr. Tangent, seeing this line, gets confused and he falls, whoa, down to the bottom there. Now, we have to calculate how far this fall was. I think we're going to need some more information if we're going to solve this problem. For instance, we don't know what the angle of elevation is of the magic line from Pythagorean to the opposite building. We also don't know how far apart the buildings are. But don't worry though. I have found Pythagorean's secret book of facts. While I go and check the information we're looking for, why don't you draw a diagram of exactly what happened for yourself? See you now. Okay, I have found the information we are looking for. But first, did you make a diagram? It's always a good idea to label a diagram. So let's call the end of the magic line A. Tangent's position let's call B, and let's call Pythagorean's position C. Now we can fill in information from Pythagorean's book of facts. We have an imaginary horizontal line from point C to the building. Let us call this point E. From C, the angle of elevation to point A is 25,1 degrees. The letter that follows the word from tells you where the horizontal line for the angle of elevation is. We are also told that the angle of depression of point B from C is 52,4 degrees. Again, we look for the letter that follows the word from C. That means the horizontal line at point C to the building, which we called point E, is the horizontal line we use. The angle moves down to point B. We need to calculate the distance that the tangent fell. But we cannot use triangle ACB because it is not a right-angled triangle. In trigonometry, we often aren't given a right-angled triangle, but we can make right-angled triangles by dividing our large triangle into two smaller right-angled triangles. Now we have two right-angled triangles, triangle AEC and triangle BEC. We can find the length of AE and we can find the length of EB using trigonometry. And if we added these two lengths together, we get the full length AB, the distance the tangent fell. Now we are ready to do some trigonometry. Are you ready? Let's go. In triangle AEC, we know that angle C is 25,1 degrees. But we are still missing some information. We need to get the length of a side. So coming back to Pythagorean's Book of Facts, the distance between the two buildings is 50 meters. So let's fill that in here. So this distance is 50 meters. And I think I'll call this point D. So I know that DB is equal to 50 meters. And because I know that DB is equal to 50 meters, I can see that CE will also be equal to 50 meters. Now we have the angle. We want to find the side opposite the angle. And now we know the length of the side adjacent to the angle. So, using the tan ratio, we get tan 25,1 degrees is equal to AE, the opposite side, divided by the adjacent side, which is CE. And we know that CE is 50 meters, so in place of CE, I can write 50 meters, but we want AE alone, so let's multiply both sides by 50. So 50 meters times tan 25,1 degrees will be equal to side AE. Calculator time. Are you ready? We now need to calculate the length of EB. Remember, we're going to add this length to that length to get the full distance of the tangent's fall. There he lies. Okay, so we have now our angle of depression 52,4 degrees from the horizontal line, the angle of depression down to B. So opposite this angle is side EB, so that is the opposite side. And once again, adjacent or next to our angle 52,4, there's the A, adjacent is the adjacent side CE. Right, using the tan ratio again, this time round we have tan, and our angle has a name, BCE, is equal to the opposite side, which is side EB, divided by the adjacent side, which is CE. Now we can fill in our values. We know that angle BCE is 52,4 degrees. We are looking for the opposite side EB. We know the length of the adjacent side CE is 50 meters. Now we want EB alone. So I'm going to multiply both sides by 50. So then I get 50 times tan 52,4 degrees is equal to EB. Let's go to our calculators. Now we have the length of AE and EB. We can add them together to find the total height that tangent fell. The length of AE is 23,4 meters. We also know the length of EB to be 64,9 meters, and we are going to add those two lengths together and get a total of 88,3 meters. The tangent fell a very far distance, 88,3 meters. I doubt he'll be able to climb back up the building. In this lesson, we were given a lot of information that we translated into a picture. We filled in the sides that we were given and the angles of elevation and depression. As the side that we were asked to find out was not in a right angle triangle, we created right-angled triangles so that we could use trigonometry to help us solve the problem. Task time! We have something quite different for you today. We want you to write a brief letter to a friend explaining what happened to Pythagorean. Use a diagram and trig to explain how we calculated the distance that the tangent fell. Wow, you made it through this lesson. Your trig is getting really good. Well done. Keep it up. And from me, Renaud, see you next time. Bye-bye.